NASA's Webb detected signs of sky on this exoplanet. NASA's Webb Space Telescope was launched in 2021. However, the telescope has been detecting signs of sky on an exoplanet for some time now. Webb has revealed the chemical fingerprint of water in the atmosphere of an exoplanet, a planet beyond our solar system, for the first time. The solar system is full of worlds with different atmospheres. Webb's latest observation paves the way for astronomers to use the telescope to study how much water is present on exoplanets. Webb's near-infrared camera and near-infrared spectrograph were used to study the exoplanet known as the WASP-39b. The solar system is full of worlds with different atmospheres. We don't know much about them, and it's not because we're ignoring them. The Webb telescope will help us learn about exoplanets by examining their atmospheres in detail. This will give us an insight into what those planets look like inside, and also help us understand why some have more water than others, and why some may even be habitable. Webb's latest observation paves the way for astronomers to use the telescope to study how much water is present on exoplanets. This is a big step forward in our understanding of exoplanets, as Webb has just launched and will revolutionize our experience of these distant worlds. James Webb Space Telescope of NASA has made another first, a chemical and molecular profile of a faraway world sky. Unlike prior discoveries from Webb and other space telescopes like NASA's Hubble and Spitzer, the most recent readings from Webb reveal a wide variety of atoms, molecules, and even evidence of active chemistry in clouds. The most recent data also shows how these clouds would appear up close, which is fractured rather than covering the entire planet in a single even layer. The WASP-39b, also known as Hot Saturn, is a planet roughly as giant as Saturn, but in an orbit closer than Mercury. Orbiting a star about 700 light-years away was the focus of the telescope's array of sensitive tools. Webb has found that WASP-121b has the most robust water feature yet seen in an exoplanet at this wavelength. The discovery was made by examining light reflected from the planet's atmosphere and finding that it contains more hydrogen than expected. This is thought to be in the form of water vapor condensed in its atmosphere and fell onto its surface, where it cooled to form clouds of ice crystals. This can only happen if enough molecules are present to condense, meaning there must be much more water than previously thought. These findings are positive for the capability of Webb's apparatus to do the extensive range of analysis of all types, the discovery of exoplanets and planets orbiting other stars, as the scientific community had hoped. As part of this, it is possible to explore the atmosphere of smaller, stonier planets like those in the TRAPPIST-1 system. The results are thoroughly discussed in 5 new scientific articles, 3 of which are being reviewed and 1 of which is already in the press. The first detection of sulfur dioxide in an exoplanet's atmosphere is among the groundbreaking findings. This molecule is the end product of chemical reactions sparked by the planet's parent star's intense brightness. On Earth, similar processes are utilized to create the ozone layer, which protects the upper atmosphere. Using photochemistry computer models to analyze data that demands a thorough description of such physics was and never early success. The modeling improvements that follow will help to build the technological know-how required to interpret future signs of inhabitability. A NASA scientist claims that the planets orbiting beneath the host star's radiation bath are being sculpted and molded. Life can flourish on Earth because of such modifications. The planet is used to evaluate the impact of radiation from host stars on exoplanets, since it is 8 times closer to its star than Mercury is to our Sun. A better knowledge of the star-planet interaction ought to result in better appreciation of how these processes affect the diversity of planets observed in the galaxy. In fact, the Webb-tracked WASP-39b, as it passed in front of its star, allowed some of the star light to get through the planet's atmosphere and enable the detection of the object's light. Due to the fact that various atmospheric chemicals absorb various colors of starlight, astronomers may be able to identify the molecules by looking at the colors that aren't present. Webb uses infrared to detect chemical fingerprints in the cosmos that are hidden from human sight. The Webb telescope has also detected water vapor, sodium, and potassium as additional atmospheric constituents. These findings are supported by prior satellite and ground-based telescope research, and at these longer wavelengths, new water signatures were found. Furthermore, Webb observed carbon dioxide with 2 times the accuracy of its earlier observations, providing more data. Carbon monoxide was discovered in the interim, but neither methane nor hydrogen sulfide were visible in the Webb data. These substances are hardly ever detected, if at all. A multinational team of hundreds of independently assessed data from 4 of Webb's telescope's carefully calibrated sensor modes to capture the broad spectrum of WASP-39b's atmosphere. Webb's instruments, NIR-SPEC and NIR-CAM, are used for imaging and spectroscopy, and MIRI for spectroscopy and coronagraphy. Work together to study planets around distant stars. The Webb telescope aims to understand how planets form and evolve through their lifetime by observing them as they transit their planet stars. This allows astronomers to determine if there are other worlds out there that may harbor life similar to our own on Earth. It's exciting to see Webb taking shape, and even more exciting to know that it will soon be providing new answers to questions we don't know enough about yet to ask. A deputy scientist commented, "The James Webb Space Telescope mission will also benefit us here on Earth by helping us understand the nature of planetary systems around other stars. This includes planets like ours, but also ones closer than our solar system like Proxima b." The JWST can resolve individual molecules or atoms within a planet's atmosphere through its spectrographs, allowing for direct imaging and chemical analysis via X-ray fluorescence spectroscopy or infrared emission spectroscopy, respectively. This advances our knowledge of exoplanets significantly and its ramifications for upcoming expeditions. Webb will allow us to study exoplanets with more accuracy than ever before. It can detect infrared light from these planets, which will enable us to see them better than we can in visible light. Webb can also capture images of planets at different stages of their orbits around their host stars, something that wasn't possible before. Webb can observe an entire planet's evolution over time, allowing scientists on Earth much more insight into what kind of atmosphere an exoplanet may have and what kind of life may be possible there. Without Webb, we'd be limited to only studying planets that are close enough for us to see with our current telescopes and how it affects their climate and how their atmosphere changes over time. Webb will also be able to capture images of the atmospheres of exoplanets and study them for signs of life, such as water vapor, ozone, and carbon dioxide. Webb's newest observation paves the way for astronomers to use the telescope to study how much water is present on exoplanets. While Webb cannot directly measure the atmosphere of exoplanets, it can provide large amounts of data that can help scientists understand the chemical composition of these atmospheres. These observations will also allow them to determine whether or not planets are habitable, which has been difficult so far because there isn't enough information about these distant worlds yet. That's all for today's video. If you like this video, give it a thumbs up and make sure to watch our other videos as well so you can find out more about JWST discoveries. Do subscribe to our channel and save us by the bell so you get all the notifications regarding our videos. Feel free to post your comments if you have further questions. We'll be back with more. Stay connected.